My biosensor lab. So how do these plasmids work? The Piton BL21 E. coli detect light. When it is exposed to light for about 8 hours, they will begin to turn a reddish pink in color. The amount of time it takes these plasmids to turn color can depend on temperature as well as exposure to light. So really the type of environment it's in is going to determine how long it takes to turn that pinkish red color. The PDUSC BL21 E. coli are able to detect the presence of darkness, therefore allowing it to turn pink or red in color. Like the Piton plasmid, the amount of time this takes should be around 8 hours, but could change due to temperature and exposure. My hypothesis. If each of my plates are partially blocked from light, then my PDUSC plates will not turn pink in the light and my Piton plates will not turn pink in the dark. The reason I found this to be a good hypothesis is because of their functions. PDUSC plates turn pink and red or red in the dark. Therefore, if I deprive them of darkness, they will not turn pink or red. Piton plates turn pink and or red in the light. So like the PDUSC plates, if I take away the thing they need to change color, they will not change color. My experimental design. So my control was a Piton plate kept in sunlight as well as a PDUSC plate kept in the dark. My change variable was for my PDUSC plates, I consistently exposed one side of the plates to light and kept the other in dark. For my Piton plates, I kept one side in the dark and exposed the other to light. How long I ran my experiment was for 15 days. I used 6 plates, 1 PDUSC control with 2 experimentals, and 1 Piton control with 2 experimentals. So in this picture, you're going to see another plate right here. That is just a kind of I had an extra plate, so I just did that on my own, so I just wanted to address that. But this is my experimental PDUSC. This is my experimental Piton, and then, or no, control, I'm sorry. Both of those are controls, and these are experimentals. And I just left them in my windowsill, that way they had light on them. So for my results, my control for PDUSC did not turn pink or red. It only had a couple white spots on it. One of my PDUSC plates that were half covered had a lot of growth. It turned black spots, and the other only had white spots. The half that I exposed to light has dusk written on it. So this bottom half was exposed to light. So on the plate with black spots, there seems to be a slightly red outer ring, but that would be right around the black spots. So my results continued. My Piton control plate has little to no growth and did not turn pink or red. On my Piton plates that I only exposed half of the plate to light shows tremendous growth, mostly covered in black dots. The dots' outer rings have a brownish red color to them, but other than that, they did not turn pink or red. The side with dawn written on it is the side I exposed to light. So once again, the bottom half is what I exposed to light, and this is the one I was talking about with a ton of growth. This one also does have a ton of growth. So my hypothesis was supported. My data did show support. My PDUSC plates did not turn red when left in the sunlight, and my Piton plates did not turn red in the dark. While these are not the results I was expecting, my data does support my hypothesis because neither plasmid turned red when given an opposite condition of what they needed. So if I were to do this again, I would do it during the summer simply because the weather is more consistent in a warmer temperature anyway, and you want the warmer temperatures to get that pinkish red color. So yes, I would do it in the summer. Also longer periods of light because the sun is up for longer. If I were to do it again, I would also invest in a light system. That way they were never ever kept in the dark, because obviously when night came around, they were kept in the dark for that period of time. So that's kind of what I would change about it, but my hypothesis was supported.